Great to see so many people here. So I'm going to keep it very short to introduce the first speaker, which is Jim Dowling. Well, first of all, I work for Hopsworks as well in the go-to-market side, primarily focusing on EMEA. So Jim Dowling, our CEO and co-founder, will do the first talk. Later on, Peter Sundström from Saab, being the head of AI, doing the second one, and followed by Jordi Spranger from Roboverse Reply. He's currently doing an assignment for the German police. So hopefully you'll find it very interesting, and great to see you here.
Thanks, Carl. Hey, we've got a little Swedish flag here. Maybe most people don't know, Hopsworks are a Swedish company, and we're fully European owned. We're a proper European company. I think we're spread. We have, I don't know how many nations we have, probably 18 or 19 nationalities in the company. Very international. But we're based just about 200 meters from here. And we came, just a little bit about us if you don't know us, we came for a spin-off from KTH and Rice, but also from MySQL. So that's a little bit about our background. I'm going to talk about, I'm going to start by talking about sovereignty and digital sovereignty in AI. And then I'm going to talk about what Hopsworks is, right? Just many of you might have heard that before. Hopefully you won't be too bored by it. Might even do a little demo. You know this Chinese phrase, we live in interesting times, right? But the unthinkable is now thinkable, right? So Denmark, our neighbors, they did a study recently. What would happen if at 8 o'clock in the morning you turned off AWS and Microsoft? What would happen to the country? By 10 o'clock, it would be shut down. Right? And we actually talked to people from a very large Danish company last week at the Data Innovation Summit. They're really worried about this. They're thinking, you know, if they want Greenland, they just turn off the companies. 2 hours later, Denmark's on their knees. Here you go. It is unthinkable, but it is thinkable now. I think we all understand that. And I think Europe has kind of woken up to this. And we're kind of here with our pants down, right? So the Chinese, they got their clouds. The Americans, they got their clouds. They got their digital infrastructure and their digital sovereignty, and we don't. And I wouldn't say Sweden's waking up yet, but we're getting there slowly. Now, this is actually an AI picture, right? It's not the original, Olof Palme. That's color generated AI. That's a little AI on this page. But I did a little bit of research because he talked a lot about sovereignty and what it means to be free and so on. And these quotes could be from now. He says, like, we used to look to the United States for moral leadership and authority, but look what's happening now. Small countries, their right and threat of independence is being taken away from them by the great powers. That really feels like history's repeating itself, to me at least, at some level. Now we have Saab talking here. Saab, to a large extent, I would say, exist as a military, let's call them a defense company, because of this philosophy promoted by the likes of Olof Palme, that we should be independent, technologically independent in Sweden. In order to be free as a country, we need to be able to control our destiny. And Don Emmelin, I think, had an article in Dagens Nyheter today, and he said, without digital sovereignty, there is no sovereignty. I think it's a great line. Like, if there's no digital sovereignty, you aren't sovereign. And I think, you know, if we had kind of not followed that approach promoted by earlier Swedish governments, would we really have this technological independence? And we don't have full technological independence, but military independence, I think. This is an interesting term, and I'm Irish, my native language is English, and I use the term strategic autonomy, and people look at me as if I've two heads. It's not a term you'll find in the Anglo-Saxon newspapers anywhere. If you say it in French, l'autonomie stratégique, everyone knows what you're talking about. Even the Germans talk about strategische Autonomie. Sweden, strategische Autonomie, no idea. I haven't seen it in newspapers anywhere. But if you look around the newspapers in Europe, you'll see they're all talking about it. Microsoft even have to now come out and say, we will protect your data no matter what. That's what they're saying, right? We know that that's not true because, you know, would they pick Denmark over their home market? I think we know the answer. But we can see also that there is actually a financial effect of what's happening. I put Saab's share price in the corner. It's public, don't worry. We can see they've doubled in price since funny date there, February. Somebody started working at that point in time in America. So what we're seeing is a realignment globally, and Europe is we're in trouble. Like, if we're to be honest, Ericsson. I don't know if people saw the news. Ericsson, they removed all their DEI references recently. They just got rid of it. And they had to deny, of course, that Trump demanded it. But of course he did. Right? We know that. And if your core values, you change your core values because you don't feel you have that sovereignty, then it really hits home that if you don't have digital sovereignty, you can't be sovereign. You can't decide your own fate. You can't decide your own values. You can't decide your own future. I think in Olof Palme's time, Sweden was one of the richest countries per capita in the world. It was, an industrial country. You could go it alone. I don't think you can do it anymore. I think most people understand that. You have to pool sovereignty to go for technological independence. And there is actually a history of us doing this in Europe, right? So many people don't know about it. After World War II, Europe was laid waste, and the Americans had obviously got Boeing, and they were selling their airplanes, and it was obvious in the 50s this is going to be the next huge industry, the airline industry, because jet airplanes worked really well. So Europe actually pooled sovereignty to develop Airbus. So many people think Airbus is French, and yes, they assemble the airplanes in Toulouse to a large extent, but the engines come from Rolls-Royce and other places, and in Germany they do huge amounts of work on it. It really is a case of Europe succeeding to build a technological platform which enabled them to be somewhat independent. So where we are today is, I use an analogy from the 1800s. We're like America if we'd invited the British in to build the railroads and run the trains, and all we're allowed to do is sell coffee in the coffee bar. That's kind of where we are. But I think we're kind of, we know that we need an EU cloud, and we know that we need EU data and AI platforms. And I'm going to talk about Hopsworks, which is an EU data AI platform. So that's it. That's the kind of the sovereignty aspect. I'm not going to go into too much more details. You can see I care strongly about this, and I really think we need to up our game. And I think it's clear, at least across many parts of Europe, that we will have to invest massively. And for those of you who doubt it and are cynical, I understand. But if we go back 15 years ago, when the euro was definitely going to crash, Draghi came out and said, we will do whatever it takes. And believe me, it will be enough. And he's come out again, and the new German chancellor came out again and said, we will be independent. Okay, so that's the bummer. But it's also an opportunity, and so if you're going to say we stay where we are, where's the future leading? Like if you work in the car industry and you're not making batteries, we're not doing it right now in Sweden. It's difficult. There's not that many moving parts in cars anymore. So if you're an enterprise and you're sending money to your AI service provider who uses the codependent cloud provider, and the money comes back, money's going away and it's never going back to Europe. So to get our economic independence, we really need to wake up to this. All right, so Hopsworks is a European-owned AI platform. I'll make sure I don't go over time too much here. And this was not great animation. I'll blame American slideware for that. But so we have a specific philosophy for building AI systems at Hopsworks, and it's that any AI system, whether it's a batch AI system, a real-time AI system, or an LLM-powered assistant, you can decompose it into three main parts. And if you're a big team, we work with very large enterprises who build AI systems, and they build batch, real-time, and LLM-powered systems. But if the teams work together, they have a unified language and say, hey, I'm building a feature pipeline. My feature pipeline will take my data, and it will create these features and labels. And that's what we'll work on. So we've decomposed the problem into a smaller problem that we can work on independently. Training pipeline will be probably data scientists taking those features and labels and outputting a model. And an inference pipeline will take that trained model and some new input data and output predictions. And that's basically all AI systems. An AI system has data, it makes predictions. I've been teaching a course at KTH for years about building AI systems. It's actually the first ever course on deep learning in Sweden. And they have a project, and they have 1 to 2 weeks to build an AI system. And the only description of their project they have to hand in is, what is your data source? It is not allowed to be static, so no Kaggle, no like big static. It has to be a dynamic data source. What is your prediction problem? And from there, you build an AI system. And there's I mean, you can look at the web page. There's tons of interesting ones, but they do everything from financial markets to air quality to water levels to anything that's now become digitalized in society. And you can potentially use data to build a model for making predictions. You can build AI services on top of. So that's the philosophy we have, and I kind of mentioned this before. But we're an open. The other part of it is we're an open platform. So many of the kind of the let's call them the larger AI platforms, they try and lock you into their compute. You can only run compute on their platform, so you can only use their framework if it's Spark or SQL. But we're an open platform. You can run compute outside or inside the platform. So a lot of our customers run on American services, of course, and American clouds. And I will make the proviso, most of our income as a company is from the US, because that's where the early adopters are. And we're very much a kind of a cutting edge company. So if you're building an AI system in Hopsworks, you'll build these 3 pipelines, the feature, training, inference pipelines, and we compose them together. So often a hard part of building any sort of system that you modularize into smaller components is how do you compose them together to make the whole. And that's what you get for free with the platform. The platform has tons of services in it. I won't go into the details, but it's a Kubernetes native platform. And it's the bit that pulls all the parts together, so you get a complete AI system out of it. So you can, BYOC means bring your own compute, but you can also run your compute in Hopsworks. And if I'm writing a batch AI systems, this is for people who are interested in how do I build AI systems. Well, with Hopsworks, you can pick any technology that you think is best for your use case. So what's happened in the last 15 years is we don't just have 1 or 2 compute engines like Spark or maybe we have TensorFlow or PyTorch. We're seeing a huge number of new compute engines appearing for specialized workloads, stream processing, DuckDB for embedded SQL, Polars for a scalable version of Pandas. And data scientists and data engineers have preferences for their different tooling. So we really support as many of those as we can on the platform because we're open. But batch systems basically look like this. You get some data coming in from batch data sources. They write to the platform. You train a model with the data that's been written, and then you have a program that runs on a schedule, and it can run on a schedule in Hopsworks, and then outputs predictions. A good example would be Spotify Weekly. Once a week, you get predictions about what songs you might like, recommendations about what songs you might like. That's a classical kind of batch AI system. And a real-time AI system is one that typically has human in the loop. So often there's a human interacting with the system, and you do something and you get a response. The canonical example is TikTok. So TikTok is obviously a video platform, but kids never search. I don't even know if there's search functionality in it. When you click and swipe, it tracks your intent, and the AI that's powering its recommendation system will guide you wherever it thinks you want to go, and it's really good at tracking your intent. It's called digital crack by many people. But the technologies you have for that are slightly different. You have stream processing, you have model serving, and all of that runs in our platform, so we support all of this natively. And then if you're building a large language model applications, often we call them agents, you may have different, you mightn't train a model. Most people who do LLMs don't fine-tune models. They take off-the-shelf pre-trained models. But they'll still have to do some work. So if they're doing RAG, they'll still have to compute embeddings, and you have to have that as your feature pipeline, and then you still need to serve that model. An interesting one I saw this week was, has anyone heard of Mistral from France? It's the only European owned and trained large language model. There was another company, Aleph Alpha in Germany, were supposed to do it. They got 700 million. They stopped doing it. But Mistral got, I think, 1.5 billion. They've trained the model, and it's really good. And they're releasing a service which is, hey, I can take your model, put it in your, take their model, and serve it in your enterprise with ChatGPT UI. And that's kind of it's a sovereign AI service, because if you work in the government, you're probably not allowed to send your data to OpenAI. You're probably not allowed to, because they're going to keep it, or you're not going to use a Chinese service. And it's really great. But technically, if you look at a platform like Hopsworks, we have customers doing this already. You just take any open source model, you serve it, and you've got a little UI, and that's your ChatGPT. That's it. But then when you have the platform, you can do much more than that. But we can see the demand is here for LLMs, for taking even the pre-trained ones have a huge amount of value they can add in any organization today. This is a little bit technical. I won't get into too much detail because this is for the nerds out there. But why is Hopsworks different? Because many of you who are here obviously are familiar with AI platforms. Maybe some of you use AI platforms today. I say, well, what is this thing at Hopsworks? Why is it different? And I'm just going to focus on the differences. I've kind of given an overview of what you can do. You can build any AI system on our platform. But where we're best is real-time AI, GPU sharing at scale. And then I'll talk about something we do about getting teams to work together in a single cluster. And I'll do a little demo on something which is coming, which is using AI to build AI. Right? So using AI or large language models to build AI systems, which is pretty cool, I think. Right, so let's talk about real time. Now, I mentioned TikTok. TikTok, the way it's built is, there's a company, ByteDance, who built it. They have what's called an exabyte-sized iceberg lakehouse. So they've got 1,000 petabytes of data. That's a lot of data. So remember, petabyte is 1,000 terabytes. And then you've got 1,000,000 terabytes. So if you're a terabyte disk, you get 1,000,000 of those, and that's your exabyte. And they have thousands of servers running Flink, and thousands running Kafka, and thousands running Cassandra, and they've built this very impressive architecture. And it is the most valuable AI system in the planet today. It creates the most value of any AI system that I'm aware of. But the problem you have as a company is, you say, I can see TikTok's really successful. I would like to build TikTok. Or I'd like to have my application somewhat like TikTok. So I came back yesterday. I was in Zalando. So Zalando are a customer of ours, and they're building. They're only in the process of building these personalized recommendation systems now. They're Europe's largest e-commerce company. I think it's pretty cool. They're now building their AI on a European platform. So we get a lot of bad press. Say, oh, Europe can't do anything. We're so screwed. We're lost. But there's no Chinese platform they can build on. And we're better than the Americans. So I think it's pretty cool. But basically, Hopsworks is designed to work on these really real-time scenarios where you get this fast feedback loop, and then it works at scale. So Zalando has 50 million or more customers. This thing needs to work at scale. We have a benchmark here where, on 168 CPUs, we can handle 1 million concurrent writes and 100,000 concurrent reads. I'm not going to go into details on it. But that's kind of, that's one of the things where we're unique globally. A lot of that legacy comes from Ericsson, actually, and MySQL. So the database that powers a lot of this, RonDB, was developed originally at Ericsson, and then MySQL took it over after the crash in 2003. And then it went to Oracle, ultimately, and then it was open source, so we forked it, and the developer of the database is working at Hopsworks, Mikkel Rønstrøm. But anyway, I digress slightly. So why is real-time AI important? Well, I think if you're building an interactive application, anything that has users working on it, everybody is adding their little chatbot here. I'm calling it Le Chat, because that's what the Mistral call it. It's funny, Le Chat. But you add a little chat window, and you kind of say, hey, look, my application's intelligent. You can type in something, and it'll give you a smart answer, because the LLM knows something. And you say, well, it doesn't know about my app, so you add a lot of information to your app in a vector index, and we have one in Hopsworks, so you can do RAG. Now it knows about your app, but it doesn't know what's happening in your app, right? So if I want to build a truly AI-enabled interactive application, I need to respond to your clicks. You clicked on this and this, but you never clicked on this. You want the agent to actually not be like the Microsoft clip that said, hey, you're doing this wrong. You want to be actually helpful. I say, I think you're trying to do this. Maybe you want to try and click on this instead, or give you advice in some way or other. But to do that, you have to do it with very low latency. If I click and it takes a minute for the system to react, it's not going to be perceived as being intelligent. And the other thing is applications don't just generate clicks, and you don't just have enters in text box. They do things, they have databases. So they'll have an application database, and that data also can be used to power an interactive AI-enabled application, and that's what we do at Hopsworks as well. So we'll take all this data, we'll integrate it, we'll call it working memory. It provides context and history for your AI systems, and you power it typically with IDs. Your application just sends in, hey, I need information about this user ID, this product ID, this session ID, order ID, and so on. That's where we're going, and Hopsworks is really leading the way. So another place that we're doing a lot of work at the moment with a very large Swedish company is They have hundreds of GPUs. So how do you share those GPUs across your organization? So you're buying them, it's sovereignty, right? You're not renting them in the cloud. So this is actually something the cloud giants don't typically work on, because in the cloud, you rent a GPU, you use it, and you throw it back. So you don't care about increasing utilization of the GPUs. You just use them, throw them back. It's the cloud provider's responsibility to ensure you're increasing utilization. But if you're on-prem and you've bought 100 H200 GPUs, that's setting you back 5 million euros roughly. You want to ensure that they're utilized to a high level. Otherwise, you're making a bad investment potentially. So what Hopsworks supports is ensuring that mixed workloads, you can do inference. So often companies will maybe have LLM-powered applications. They're being used during the day, and at nighttime, there's not so many users. So we can run a lot of training jobs at nighttime. But if I have a cluster, I'd also like to do scalable compute, like run things like Spark. So we support all of this in Hopsworks. It's built on an open source framework called Q. And the way it kind of works at a high level, sorry, it's a little bit technical, but you basically take your organization and say, well, I'm going to put some GPUs over to the dev organization on the left, or your right, and then on your left, I'll say I give a bunch of GPUs to the GTM organization, and they're kind of separated. You could have them all under one umbrella, but you can basically split it up if you want to. And then within the GTM org, we've got a bunch of business units here. And you can see that business unit 1 is given 4 GPUs and business unit 2 is given 2 GPUs. They're guaranteed them. And in Hopsworks, anyone who's used it here, you'll say, well, I have no idea what a business unit is. Well, you configure this in the background, but in Hopsworks, we have a project. So everything in Hopsworks is a project. So when you're a member of a project, like a GitHub repo, you can run jobs, you can run notebooks, you can deploy models. And every time you do that, it'll request GPUs from this shared pool. It does fair sharing. There's priority for GPUs. If you're a low priority job, somebody else could take it from you. But what we can do as well then is that this business unit 1 has used its 2 GPUs, but there's a spare one over in business unit 2. So we can submit a job to a project, borrow it, and this basically helps ensure GPUs are widely utilized. And then there's a little bit more here, because if I want to do a training job and it's got a lot of GPUs, like I need 8 GPUs, I might like them to be co-located on the same host, not to be spread over the network, because then it will be I/O bound, network I/O bound. So we have support for that's called topology-aware scheduling as well. So the next thing I want to talk about that's unique to Hopsworks is what we call project-level multi-tenancy. So if you're building if you're deploying a Hopsworks cluster, every time you have a new team that you want to onboard or a new project, you don't have to deploy a new system. Because often you'll have sensitive data and you'll say, I've got this data running here. You don't have to deploy a whole new system for every team or business unit or any group of people working on sensitive data. We can run them all on the same platform. So a typical organization would be that you have maybe one project for everyone in the company. We have all departments here, and then you have different projects for different business units or teams in your organization. And then there is the ability to share data across these business units or projects if the needs require that. So the way it works if you're using Hopsworks is you'll be a member of a project. It's just like a GitHub repository, and you say, hey, Jürgen, Bob, and Alice are members of this project. They'll have access to all compute, GPUs. They'll have some quotas for GPUs. They'll be able to store their models, their data for training, their data for serving, and there's some usage tracking. But any given user can also be a member of 2 projects. So Alice here is a member of cyber and a member of narcotics. Now, what happens if Alice runs a job in cyber? Can she copy the data to narcotics? Well, the answer is no, because in every project, Alice has a project-specific identity. So the identity of the user running in the cyber project is not Alice, it's cyber_Alice. And similarly, in the narcotics project, her identity is narcotics_Alice. So in the system, when your Ray job here tries to copy data over to the other project, it'll say, don't know who that user is, CyberAlice, not going to allow you to copy the data. And this way, we basically ensure that these are sandboxes, these different projects. Within a project, you have role-based access control, because if you have a project and you're trying to be compliant with the ever-changing EU legislation, The obvious one being GDPR. In GDPR, you have owners of data and you have processors. So we have a security model that reflects those two roles. So you have data scientists, they'll maybe train models, or they'll do some processing, and you can have a data owner who is responsible for membership, but also for they have privileges to update feature data or deploy models and so on. And then, of course, you can share data across these different projects in a controlled way. And actually, in the latest version, we're enabling column-level access control, and then row level will come in the version after that. Right, I'm going to just show our assistant. I'll do a quick demo just so you get an idea of it. But I said that we're building AI systems by decomposing an AI system into three parts: a feature pipeline, a training pipeline, an inference pipeline. One of the things that we get when we go to, particularly to large enterprises, is like, yeah, my data scientists can write a training pipeline, but they're not very good at the feature pipeline. It's hard, right? They're like, we got the data, it's in Snowflake, and they don't know SQL, they don't know Spark, they don't want to do it. Can you make it a bit easier? And two trends we've seen in our space is point and click. Like there are a lot of tools out there where you point and you click. And this is a kind of a way of building these data processing pipelines. You say, data comes from here, I want to do this, and you check the drop-down list and say, oh, that's what I want to do. And then you put the output, you put somewhere else. Obviously, compared to writing code, if you're used to writing source code, it's a much more constrained environment. The idea is that it should make you productive, though. But what we see nowadays is that, I think people are more proficient in programming the likes of Python. You can put your code in a source repository. It's now an asset. You can share it. People can modify it, update it. It's flexible. You always want to do the latest, newest things, newest libraries. So the point and click thing is kind of, I would say it's under threat. And the other one that's under threat is saying, well, Python is too hard. Let's have a domain-specific language, and we'll make it even easier than Python. So what is even easier than those approaches is to use text. So why don't we use text to create these pipelines? So why don't we use an LLM or an AI to help us build our AI system? Now, as we're Hopsworks, we had to be on brand, and we called it brewer. You can also brew coffee, in case you were thinking it's just beer. And I will at this point plug that we have Hopsworks beer out there as well, if you're curious. We do actually make beer as well. And yesterday I was in Berlin, and that's where we got the name for Hopsworks. We had to give, the platform was called Hops, and our first talk was in a brewery, Kulturbrauerei in Berlin. And somebody had a joke and said, let's call it Hopsworks. It sounds like a brewery. And then we ended up with that name. Anyway, so let me just show you how it works at a high level so you get a feel. And there's 20 different things that can go wrong in this as I currently stand here. But let me, so this is Hopsworks here. And it's you can interact with it like with API if you just want to work with code. But here you can see your data, where your data is coming from. Maybe I'll need to did this thing. Yeah, you can see this is what happens. I just need to port forward this thing. Okay, there we go, that worked. So, I've got a bunch of data sources. So the data doesn't all have to reside in Hopsworks. I've got data on Redshift and Snowflake. It's going to access it from here. But I have tables. Some of these tables are in. So this one is in Redshift. This is in Redshift. This one is local. This one is in Snowflake. So you have these tables of data. So you can have a look at a table of data. This one's in Snowflake. You have columns of data. We have telling us where it's coming from, how it's being used with lineage. You can have things like data validation rules. You can have a quick look at the data that's in there. But what data scientists often do is they want to basically take these raw data sources and say, hey, I got to build some features. So I'm going to extract some data from it that I'm going to use as input to my model. Now you might go, what the hell is a feature? The feature you can think at a high level is a compressed representation of a large volume of data. So maybe you know what the stock market is, and you have stock prices that go like this. Well, if we talked about the 30-day moving average, that would be a feature because it's a compressed representation of the stock price over a longer period of time. You don't need as many data points to represent it. We do that a lot. Like, for example, if you're working with e-commerce, you might say, okay, I'm going to look at how many clicks you made in a period of time or the activities you've done, but I wouldn't put all of the activities in. It goes a little bit too slow for some types of models, so I can compress them into a smaller representation that has a lot of information content. So what was I going to do? Yeah, I was going to do this because I'm totally useless. I'm going to just basically say, hey, please analyze one of these tables of features, right? So I can ask my LLM. So what it can do, what LLMs are really good at is writing Python code. They're not very good at SQL. They're also very good at giving them a ton of data and saying, summarize this or analyze this. They do hallucinate. But this one I asked it, like, hey, tell me what's in this feature group called category. Now, one of the things you do as a data scientist, you'll want to see, I've got data there, tell me about it, what's in there. This may not be super interesting for many of you, but I just basically ask it to get started to do that. I can also say, and this is a really simple one, for those of you who are data scientists, please forgive me. I can say, I want to create some features from this feature group. I'm not even telling it what I'm going to create. I'm just saying, just create some. I don't care, right? So it's in this case, it's just going to go through it quickly, and it's going to look at the metadata for this table of features. So one thing that we do that's a little bit different is we have descriptions of the columns on the tables and descriptions of the tables, and extended metadata. And LLMs love all this. They eat it up to be able to reason about what type of features to create. And it basically says, hey, you know, I've done some analysis here, and I've had some insights, and I'm going to create it's going to do a profiling now. So it does some profiling. So what's happening in the background here is that it's actually creating Python code and running the Python code and analyzing the outputs, and then it's passing the output back to itself. LLMs are becoming what we call agents. So what an agent is typically is not just a single ChatGPT request, answer this question, give me an answer. They're often multi-steps. You basically want to give it some notion of a thing to do, let's call it a task, and you say, go off and do this task, please. So here you can see it's creating Python programs, it's running the Python programs, and then it's actually, this Python program is the one to create our features. So it did some analysis first and said, I'm going to do this, and it's going to create a new binary feature called is Swedish category, and it's running now a program to create that feature group. So when we go back over here and we refresh this, we should get a feature group. It might be created at this point in time. I'm not sure if the data will be in there. Okay, so it's actually just creating the program for it. But that gives you an idea of like what, where are we going? Sweden, okay, so it created it here. So it created this code. Now, you know, what LLMs are very good at is if they make mistakes, you can basically tell it to self-correct. You know, so what we do here is we'll create a Python program, and instead of having it write directly into this table, we can mock it and say, hey, try and make sure the syntax is correct before you actually run it. And if there's a syntax problem, you feed it back in and it fixes it. So it's not like super fast at the moment. This will get faster. But it gives you an idea of kind of where we're going in the space. So that's the quick demo. It gives you an idea of what we're doing, and that's where we think we're going. It hasn't been released yet. The platform's pretty big. There's a lot of stuff. Some companies do just real-time AI. Some companies do just LLMs. Some companies use the whole thing. But really, it's a platform for doing all types of AI, batch, real-time LLMs. So if you want to find out more, we do a bit of you know, content in the community. We have a feature store community that we organize globally. We have an interesting new blueprint. I think it'll get mailed. I was told by marketing that I should tell you it'll get mailed to you. So apologies for the spam, but you're at a Sovereign AI meetup, so you're going to get mailed with this blueprint. It's a survey of over 100 professionals in the area around Sovereign AI. If you're more into for the tech, this is the first. I think it's 6 chapters are here. So if you want to take a photo of that, you'll get 6 chapters for free. I've written 13. I have 1 left to do. So the book will be finished soon. It'll be out in the summer. These things take time, but it's a journey. But it has an end as well. So that's it from me. We now have a couple of talks. I think it's Peter next from Saab. Peter's up next. And then we'll have Jordi from Reply.
Welcome to my presentation about AI application and electronic warfare operations. So, who am I and why should you listen to me? I am the head of AI for electronic warfare since about 2 years. I have worked 23 years within the electronic warfare domain. I've been coding since I was 11 years old, and I have developed signal processing software for several electronic warfare systems. And I wrote the interleaver for the tornado. It's difficult for the most of you in here to understand what that is, but it's very cool, I promise. After I had this presentation, some of those pictures in Rome last week, a pilot came down to me and said, "Thank you for the interleaver, it is so good." So, quite nice to get. No one at Saab has ever said something like that. Lessons learned during doing that was that it is very difficult to create an electronic warfare system that works well, but it's pretty easy to make it one that works okay. When writing it, I realized that what I want to achieve is pattern recognition, and it's so difficult to achieve good pattern recognition within rule-based code. So when I joined the AI hype around 10 years ago, I realized that this was the way we should write such an interleaver and identification procedure. That's the way it should have been done from the beginning. And that's what we are working with now. And within the field of electronic warfare, AI is not a hype. It's needed to create this situational awareness picture that we actually need. Okay. This is more on a higher Saab level. Adapting to the future of defense. AI has a transformative potential for defense industry. And we have to focus on creating solutions in-house together with partners. And now I have to mention Hopsworks, of course. Saab also has a partnership with Helsing.ai in Germany. And the fields that we are doing AI for are, for instance, multi-domain distributed sensor systems and autonomy unmanned systems, electronic warfare, which is a field that I've been in for the last around 23 or 20 years, something like that. And for all this, of course, we need artificial intelligence. Here are the domains that we work with within Saab. We do a lot. It's quite impressive that with 25,000 employees, we can achieve such systems. We do sensor for all those systems, and we do everything. We build aircrafts. We build the mechanics, we produce the electronics, we design the RF modules, and we create the software and create AI and make all that work together. Not many companies can do all that. The most common question, the question I always get, what problem are you trying to solve? And I always feel like, okay, let's go back to square number one. Why do we need AI? When we try to, what we do, what electronic warfare is for us, we have sensors on the aircrafts to sense the radars that are trying to see us. And we need to identify what is this and where is it and how dangerous is it. And in the past, it was quite easy to do so. The radars kept themselves within a small frame, small limited frames, making small boxes. There are three different parameters on the axis, and it worked pretty well. Since the boxes are small, they never overlap. But for future radars are becoming more agile, so they spread in the parameter space, the boxes becomes larger, and it's difficult to see what is it. Difficult to identify, creating ambiguities. So we need to find other ways to identify what is it, looking into more details inside the signal, and then we can achieve better identification. And to do so, we need to do pattern recognition, and for that, machine learning is much, much better than rule-based coding. Okay, and this is another looking at it from another perspective, and this is to classify how dangerous is the threat. We can see that the parameters are spreading within the same limits, but the patterns are different, and we use machine learning to identify what is it. And this is very simple data. In the reality, it's much, much more complex, but I can't show that because it's secret. So let's keep it simple. And The next common question I get is how do we get the data needed to train the models? Not possible. The customers wouldn't give it to us. The customers are Swedish armed forces, for instance, or other countries' armed forces. And it's very, very classified information, so not even we can get it. Okay, so what do we do? In the past, a lot of time was spent on model development. Some time was spent on data annotations, and quite little time was spent on synthetic data generation. At present, we do less model development, more data annotation, and a little more on synthetic data. But what we see in the future, or that is actually now, a lot of time will be spent on synthetic data generation. And when we do that, we get annotated data automatically when we generate the data, and therefore we can train the models much quicker. Closing the loop, reducing the time of the loop, simply. And how do we do that? Well, this picture is not so good, but what we do is that we define what does the radar emitters look like, set up the parameters. And then we define the space on a map and saying, like, within this space, let's generate 100 threads. And within another space, put in other threads and so on, creating a very complex environment on the map. And then we define a flight path that we fly our aircraft through that. And then we push the generate button and generate all the radar pulses that would hit the aircraft if we flew through that environment. Then we get lots of data to train the model on. But that is not enough. We also need real data, some sort of measurements, so that we know that we are on the right way. And so, since we are Saab, we have our own aircraft. We can fly them around, measure, and we can get something like that. Quite difficult to get, quite difficult to understand. It takes a lot of time to analyze that. And to annotate it dot by dot would take too much time. So as I said, we will need AI models to sort the data and annotate lots of dots or data points at the same time. You see the yellow line there. You can see that those dots are probably belonging together. So if we click on one of them and then use an AI model to realize which dots around this belongs to this from the same source, good. Then we can highlight that, and then we tell the machine to let's annotate all those dots or data points to the same thread. And then we can use that to train models. Let's see if I forgot something. I think I got that. Okay, so where do we want to use AI for electronic warfare? We have defined this. How do we reach cognitive electronic warfare? And we have found out that let's start in the analytics tools that the customers are using. And in there, we define. In there, it's quite easy because it's not so time critical. So therefore, we can create a system that works. And that is in the pre and post mission analysis. And we can store all the data in a large database. And we can check whether, if we see something that we don't think we've seen before, we don't know whether we've seen it before or not, we can check in the whole database, have we ever seen this before? And what did we define it as then? And update the database. And when we have that working, we can move on to real-time analysis. And that is when we download the trained models on a real aircraft and use it in the real world. That's in there we have 3 steps. First we have it in one aircraft. But after that we realize that, okay, what if we want to take this to the next step? let's have AI models in several aircrafts and make them communicate with each other. And then we can define an even better situational awareness. If aircraft number 2 already can get the message from aircraft number 1, don't fly here, it seems to be dangerous, fly there instead, or something like that. And finally, we hope to reach some sort of cognitive level, which is quite hard to define right now, what it actually is. But as I see it, it includes self-learning during the flight so that we retrain the models as we receive new signals. And also apply jamming against the threats and evaluate the result of the jamming, so whether we can change the electronic warfare battle space or not. And here we have a simple example of what the very simplest model that we could think of. Let's say that we have a signal that looks like we have the frequency, a step-radial frequency emitter to the left. And we train a GMM, Gaussian mixture model, in accordance with that signal. Then we would get a GMM that looks like the signal described to the right. And after that, that GMM will recognize that kind of signal in the future. That will, of course, not be enough in the long run. We need much more complex model to be able to sort out more complex signals. And sorry, but I can't show you that. Then I have this about edge. First, let's say something about this picture. 20 years ago, I wrote the software for such a system. This is a flare dispenser system, and it is a jettison function, and that means that you fire all the flares that you have at the same time, and that you only do that if it's kind of a crisis. The aircraft has to drop everything at the same time because otherwise we will crash. But the program that I wrote was more like, let's throw those flares out in such a way that we get the highest chance of defeating the threat. It's like if you're hunted by a missile, that worm-seeking missile, or what do you call it? Exactly, thank you. If you fire a flare, and it will go for that instead of the aircraft. So I optimized the routine for that. A quite cool thing, actually. I did it for a helicopter, though. I didn't do it for that aircraft. This is 2.0. I did 1.0. Then we come to this, what we also want to do in the future. Multi-source data fusion to reach intent recognition. Performing radar warner function is good, but what if we can combine the measured signals from several sensors into one situational awareness picture? Then we can achieve an even better picture. And that can be done like this. Let's say that you have passive sensors, you have active sensors, you have satellite pictures, and some open source data. And you feed all those into a massive data fusion service. And then after that, you can select information, select portion of the geographic position. And on the height, you have the time. So then you can follow something like a harbor to check what vessels have been in this harbor. And in theory, you could even follow a vessel, how it travels over the world, and build knowledge about how are things moving. And learn about that, and sometimes you find something that is not so good. And this is a sort of a description of how to do the fusion. Different sensors, you have different sensors at different times, and combine them together as good as you can. Sometimes, well, when your aircraft is not flying, it can't measure, and then you don't have it. And when you have it, you use it to build a better situation awareness. Okay. So why am I interested in Hopsworks? How does this fit in? I would say it is not so smart to do everything by yourself. If you ever think about building a platform, then don't. I heard yesterday. Sorry, Jim. But we are Saab. We are used to doing everything ourselves. So this is kind of an exception that we have a collaboration with the platform provider, which I'm very happy with, that we can, since we can always go here to Södermalm and meet you and get input on how to use your platform. This is a picture I drew quite a long time ago. But what we want to do at Saab is the top of this pyramid. That's the AI functions that we want to achieve. But to be honest, the rest I don't want to do. I just want it to work. I think Hopsworks provides something in the middle of that. And since you provide that, then we can move on with what we are good at. We're not good at creating this pyramid anyway. And as for Swedish industry companies overall, it would be great if we can collaborate around this. Instead of everyone building their own pyramid, everyone should be building their own top of the pyramid, I think. But what are the functions we actually need from the pyramid then? From Hopsworks. I wrote something quickly here, like when I came here. And this is what I think that we need. We need, and you also talked about data lineage, for instance. We need the ability to trace a single data packet. That could be a radar pulse, radar track, a mode and emitter, a weapon system platform, whatever. We need to be able to track it, to trace it to its data sets, and which models were trained on this data, and from which recording did it come. And we need to prevent leakage from training data to evaluation data sets. We need the data annotations to be stored and traceable, updatable, version controlled. And I hope Hopsworks helps us with that. But we are getting started with this now. It's going to be very exciting to see how far you can take us. You look confident. I like that. And we need our models. We need to be able to have model version control, including back pointers to dataset collection, annotation collection, clean and transform script, training scripts, including hyper configuration. I don't know what I wrote, sorry. We need to orchestrate training, orchestrate test, orchestrate deployment in pipelines, security and access control. And we need the ability to collaborate within the teams around this, which is quite difficult if you don't have a data platform. So that's what I think right now that we need Hopsworks for a start. I hope I have got it. I hope we have a match.
It's a subset.
It's a sub. Yes, I know. You can deliver much, much more, but we need to start somewhere. So I think that was what I intended to say. So thank you for listening.
So, I hope you had a good break. Really cool talks before me. You know, when you're the last presenter, usually the audience is thankful if you are doing it the shortest, so you're closest to the bar. So my talk will be the shortest today. My name is Jordi Spranger. I'm here on behalf of Roboverse Reply today. And the topic is going to be public safety. And I will just tell my story, how we got into public safety, what we're doing there. it's also a lot of confidentiality in my project, so it will be really high level, but I'm really happy just to dive into it. So maybe let's start in. I will do a little introduction on us as a company and the offering, because I don't think that we are well known in Sweden yet. Or maybe other question, anybody knows Reply? No? Aha, the one that's been working with me. Okay. All right, just very briefly. So Reply is an IT consulting company. We're based in Italy, headquarters in Turin. And we are actually pretty big. So these are the numbers from 2023, which is here, I think. The headcount is not shown, but it was around, down there, 14,000. I think we are around 15,000 people now. We do IT, digital service consulting, and we have a lot of divisions. And I'm in the Roboverse division, which means that we do mobile robotics, and we are the primary integrating partner for Boston Dynamics in Germany and DACH region. Which is not only Boston Dynamics, so we do all sorts of mobile robots. Maybe you've also seen the crazy robots from Unitree, the Chinese. They have a lot of going on, or Figure and so on. That's the kind of robotics that we work with. And let me show you a little bit what we're doing here. So all the mobile robots that we work with, they are platforms. And if you ever done anything with robotics, it's really just module-based. Yeah, so you have a mobility platform, and then you put all sorts of sensors on it as you need it. And this is kind of our offering. We integrate this a lot for big infrastructure maintenance and predictive maintenance and so on. And the way we got into safety industry is that we worked with the police in Germany. Germany is federal, and we have different counties. We're working with the biggest one, which is North Rhine-Westphalia. It's in the north. And here, for example, you have a case we did with the police and their innovation branch, where we use mobile robotics with the bomb defusal team and our VR, XR expert team. And we developed a solution where essentially you can do remote bomb defusal, as well as X-ray imaging and these kind of functionalities. This is just one use case. So we're also working with nuclear power plants to do predictive maintenance on them. Also with water dams to check for internal leaks, cracks, and all these kind of situations. Also the port in Hamburg, for example, the big one. We do some maintenance here. And it's a really interesting field. So this is kind of the background of my company, what we're doing, and how we got in contact with the police. But my work that I've been doing in the last half decade is more data science and AI driven. And as we got in contact with the police, we did, and we're still doing a lot of robotics use cases. But then AI and IT infrastructure, sovereignty, came more and more into importance. And this is kind of where we got in. And now this is like, today I want to tell you a little bit about the story on what is going on in the public sector in Germany, especially the police. And what is kind of the mindset, the thinking, and the high-level direction where it's heading towards. Yeah. In 2022, we took, or the police took into operations one of the largest private clouds, which I don't have the exact numbers because I cannot disclose them, but it's really big. And essentially, it's the reason behind that. So you can always make this make or buy decision, right? And also what the presenter said before me, if you're buying like a sovereign cloud from US providers like Azure, GCP, AWS, and so on, you are dependent, and also you don't have this legal certainty guaranteed that you're really in charge and will be in the future and will be supported in the future. So this is a big risk. And there were also a couple of other reasons. There's actually a paper for this project online that can be read, but this shows you a little bit the mindset that's going on currently in Germany. And here was a decision made back then to make a sovereign IT infrastructure. Back then, not AI focused. So 2022, you have to think it was taken into operations, which means it was planned probably a decade before, if you know anything about bureaucracy. But this is kind of the mindset. This is where it was set, and this is already the direction we were heading. And now I wanted to show a little bit the macroeconomics a little bit. If you look at the data growth in the world, it's exponential, and you can see that it's a chart that goes up a lot. And this also has, of course, impact on the security, public security. What does that mean? So the police has more and more data that they need to process, or that they should process to follow up with crime. For example, in the internet, there's a lot of digital crime happening that just cannot be tracked because you don't have the resources. And the type of crime and evidence material and leads you should follow up with, it scales with the data. And you can see that even if you have the largest workforce in the world, eventually you will not be able to match the curve, right? And there's another major thing, which is the distribution of the population by age, right? So we have the baby boomers, and I don't know, any boomers here in the house? All right, that's good. Well, they're a big part of the workforce, right? And you can see now that they're slowly heading to retirement, which is also not good, given the previous trend. So you're losing out on labor force, really. So that's another big factor. And then the third also big factor is that in all and everyday life, if you're a citizen, and Sweden is actually pretty good with that, I know the Scandinavians are leading with that, is the digital services you can get in the public sector are really quite mature. In Germany, not so much. So we're really lacking behind that. And if you look at the private sector, right, DoorDash, WhatsApp, whatever not, it's an on-demand service. You want it, you need it, and there's really no reason why you shouldn't have it. Yeah, and the same should be applied, and is also the expectation growing in the population towards the government and government services, public services. Yeah, so these are kind of three macro trends that we have to take into account, that the police is taking into account. And if we think about it reasonably, the only answer to this is really digital services, automation. Yeah. And this is what I want to talk about for today. So we're currently in the progress to take the 2022 IT data center that the police has built and advance that further, that it can actually meet these demands, and also meet these demands with advanced automation. And advanced automation is mainly based on data science, AI features that can really allow you to do automation on a mass scale, or supportive automation on a mass scale. This is really already where my slides end, because I cannot share so much, but I would really like to talk through each of these issues that we're currently facing and tell you a little bit about what's the journey been with the police at the moment. So the first part is the legal and regulatory challenges are pretty big, and we are still quite behind with there's something called Datenschutzbeauftragter in German, which is data protection responsibility, and such jobs where people have to kind of give an okay for services if they are in accordance with GDPR and itself data protection and that sort of stuff. And this is currently, there's not so many people that can really push for that. There's a huge awareness of risk avoidance. So you really need to get people that can take charge, that know their stuff, and that they can give a seal of approval. Because without a seal of approval, in Germany, you will not be able to get anything on the road, really. So we're really lacking here. We're building up our competencies, and yeah, I will get a little bit more into how can we actually achieve that, because this is a systematic problem, and for that we need tools, and this is something then where we go a bit technical. The second thing is data and model governance. So currently, data, the way it's being handled in Germany is you basically cannot use it because you don't have processes and tools that allow you to do it in accordance with what you should do. So there's a huge blockage here, and you're just really being, you cannot actually execute on your ideas. Then the technical infrastructure challenges. This is something quite interesting. So from the public data center that we had in 2020, we have a legacy operation model. What does that mean? So if you want to get something done and you are a user, you want to get an application into services, then you need to make an IT desk ticket. And the platform owners and operators, what will happen in the background, they will receive a ticket in a ticket queue. They will see your request. They will eventually work through it and then process it. And then maybe your service will come into live and you can use it. But then it's just statically available, and you cannot do much afterwards anymore with changes, really. And that's a problem because there's a really long time window between making this ticket and actually using the service. And if we know anything about AI and data and the agility aspect of it, this is like a non-acceptable organizational IT operation service. Yeah? So if you work this way, you will most likely disappoint everybody who will use a AI service that is somewhat attached to a dynamic distribution of the process it's trying to map. So it's trying to chase some goal. If the goal changes, it will be totally useless in like a week or two, but you will need another month or two to update it. So this is a struggle that large organizations have, and this is just a form of, is your organization actually AI ready? Like, do you have the processes and are people enabled to actually get the functionality ready? And that's currently a big problem. If you look at the public sector, people cannot be fired. They have this legacy model of doing a data center, and we have to change that. And that gives a lot of friction and a lot of politics. And usually the boomers, don't really help in this sense. And here, besides actually doing it technically with tools like Hopsworks, there's just a mindset shift that has to happen and an organizational structure where we enable teams to actually perform and be able to do their job. And the way we've been trying to address that is we've been looking at the cloud. If you look at the cloud, it's all, the terms maybe MLOps, DevOps, infrastructure ops, perhaps. And what does it really mean, ops? Yeah. So ops in itself, the core principle behind it is that you have an expert team that can provide you with tooling, but this tooling just enables people to get their job done. That doesn't mean that there's an IT ticket for an expert that actually does the work for you. He just gives you the tooling that you can actually do your job by yourself within a well-defined rule set. Might sound complicated, but let's look how Azure, AWS, GCP does it. You log in, you have a console, you have a roles and rights access profile, and then with this profile, if your admin allows you to book virtual machines, databases, whatever, you can just, within the realm of scope that you can act, you can book it yourself, and then you can just do your work and allocate the resources as you need, and you are enabled to do your work. And this is something where we need to get the police or also other German institutions to get going, where they enable teams to really do the work themselves, but within the rule set that a public organization needs to fulfill. Speaking about governance, audit, security, access, isolation, failover, and so on. So this is a big challenge, and this is something that general organizations, public organizations, institutes have to change towards. Okay, then the cybersecurity and isolation. So for the police, it's obviously very important that we have the maximum security on our data. Why? We work with child pornography. We work with very high sensitive data, and we need to have the sovereignty and the ownership of this and the protection that we can work with this data. And that's why sovereignty and our own infrastructure is crucial. Yeah, that's just a requirement politically. Then furthermore, the talent and capability gaps. So after the police made the decision that we should make our own infrastructure and own data center, there is a gap between teams that know, let me phrase it this way, expert teams that can really get the ground running and develop a tool set, a platform as a service for users to develop their use cases and get intelligence in the police processes. And here there's always the question, buy or make, right? So actually, if you have enough time and resources, you can make a platform like Hopsworks or other tools, labeling tools yourself, and you can make them enterprise ready. But in practice, this is of course not really feasible. That's why when we looked for a software that can help us to enable us to have enterprise-ready software, we were looking at Hopsworks, and there in our case, they were really fulfilling our needs because they provide you with the enterprise capabilities of owning your data and giving the governments the security, the access on the data within an organization. And an expert team, which is doing platform operations, like a platform operations team, can then manage them and admin it. And but there's another side to this. The expert teams that we hire, they usually want to select their own tools, and they also want to build a platform that is ready for the organizational needs. And there's a differentiation besides Hopsworks. There's also other providers like IBM Watson X, HPE with the Emerald analytics software platform, and they have a bit more of a philosophy of a lock-in or a platform that should cover everything and is not so extensible. What we found is that in the area of ML ops or machine learning itself, it has changed to the side that open source tools become more and more available, and that the future is really a little bit uncertain. So, 3 months ago, 6 months ago, the kind of frameworks and tools that existed and that a platform would like to use to provide their services has changed drastically. So in the future, our expert teams that do develop and administrate the platform, they also want to have the flexibility to extend the platform as they need it. And for that, you really need software solutions that, if they are part of your platform, provide interfaces to be extendable programmatically. And this is not a given, and for Hopsworks, this was the case. And that's why currently we're exploring the opportunities with Hopsworks to be part of our platform, to grow with it, and eventually in the future, when there's changes in the AI scene and the open source tooling scene, that we can extend our platform accordingly. Yeah, I think that's pretty much what I wanted to say today. I wanted to also leave a couple of minutes for a discussion, because this is public sector. If there's any questions, I would really like to take them and discuss them here as a panel as well. Yeah.
So if there was the option to not have a completely private cloud, but a European owned or provided cloud, would that be an option for the German police use case?
It depends really. So the police themselves, they would like to have the ownership over the infrastructure. So probably as of today, the political will is really to own it. Yeah. And to extend it. Anything else? Otherwise, yeah.
Sure.
I've lived in Germany for a couple of years, so I'm very familiar with the German philosophy. And Sweden's very different, right? So Sweden, I think I saw in Denmark, I mentioned earlier, Denmark would go down in 2 hours because I think 30% of their email runs on Microsoft. In Sweden, it's 65%.
Okay.
And in Germany,
Congratulations.
in Germany, it's like 2%. It's much less. But what would you say to people? Germany is the motor and engine of Europe. What efforts are Germany making to kind of make this leap? I hear the term Luddites. Germans are Luddites. They don't believe in technology. what internally in Germany? Where's the culture going? Where are people thinking that we're going to go?
Yeah, the 2% outlook you said is because the rest is fucks. Well, the mindset is really going towards we have to be more European. We have to be more independent and sovereign. It's just also the political climate. In the end, the public services are a execution of the political will. Yeah, so this triples down. There is a strong sense that we have to have a success story, right? So America is driving a lot of success stories with their public clouds. They're totally dominating. I don't know what SAP cloud share is, but I would say it's probably single digit or less. And what we need is, there is the will, there are the funds, but what we need in Europe is we need to have a successful example of a sovereign cloud that works and really provides the services that are excellent or very good. And once we have this breakthrough where we can have this, I think it opens the doors to really extend to different countries, governments, political organizations. I know that we try to always be in touch with other organizations within Germany, also outside of Germany. And the problem is really people don't know. Yeah, people don't know what the options are. And even if they know the options, for example, Hopsworks could be a good solution for them to work with, they don't know how would that fit into their overall strategy. So they really need guidance on how do you actually use these tools? How do you make a successful story? How do you not have data breaches and all that? So there's a lot of learning.
So I guess many people have heard that Germany are going to invest 200 billion euros in defense. When I heard that, I was like, okay, we're going to build the European cloud. I mean, your guys are going to build it. Is that the mentality that money? I mean, Americans, as we all know, DARPA, in the American Defense Agency, invented the internet. They've used a lot of their money to invent a lot of the digital infrastructure that powers our society is defense money. And I'm just wondering, in Germany, is their mindset that the money that will be invested in defense now will also be used to digitalize infrastructure? I mean, to build the European digital infrastructure. Yeah. Is that part of the goal, do you think, or is that not part? Is it mostly just the Ukraine war?
Yeah, I think there is no, so there's no public statement to that, for that. But what my feeling is working with this is there is definitely a shift towards this. However, the feasibility is somehow not clear, which is ridiculous because we have really good engineers, we have really good people, but usually it's less of a can we actually do it with the right people and more of a leadership problem that there's some uncertainty on what the right decision is. That's why I would come back to the success story. So we really need a European success story of an AI/digital services. AI is just a tool to get you to digital services, but we really need a working prototype of a success story for digital services that is scalable, and then I think this will trigger the justification for a lot more that people really want as well on a political level.
I'll just add, because many of you will know that we had one and we lost it. It was Apache Flink. It was developed here in Stockholm originally, taken over in Berlin. And now the Chinese, all of Alibaba, everything runs on Flink. It's European, Berlin-based tech. But anyway,
Okay.
and hopefully we won't make that mistake again. There was a question over here.
So how much do you see the hindrance in Germany as being the lack of a sovereign platform versus the lack of German models, for example? And do you see that sovereign platform as being a prerequisite to building German models that would be hosted and trained?
You mean models like LLM models, or?
We could say LLMs, sure, but models with, let's say, German context. LLMs if it's suitable for the question.
Sorry, can you repeat it one more time?
So right now in Germany, how much is hindering Germany for doing the things they want to do? How much of that is having a sovereign platform versus having a German contextual model, whether it's an LLM or whatever other model might need German contextual information? And do you see the sovereign platform being a prerequisite for solving for building a German model? And again, LLM, if that's the easiest example, great. We can.
So I mean, there have been initiatives. Jim, you said it before, Alep Alpha. Yeah? Actually, we were interested with working with them, and they had a crazy amount of funding, but something went wrong. And that's the success story part. Sorry if I repeat myself here, but it seems like the funds, and there are funds. I mean, Germany is pretty rich. We have low debt. We can afford something. We spend a lot of money now on the war budget. It just is missing somewhat on a success story. There have been actually some German initiatives for LLMs and models and such as well, but they have never been that well funded. And in return, there is, I'm really, for me, it's also a bit confusing. I think it's, that's just my feeling. I just think the people in leadership are so unfamiliar with the matter that they make really terrible decisions. Yeah, because what was the funding for Alep Alpha?
I think they raised like 600 million or 700 million.
I mean,
euros.
how can it be? You're in Heidelberg. This was in Heidelberg, Alep Alpha, really good university city, also beautiful city, good to visit. But you have so much funding, and basically you don't get done anything significant at all. Or even though anyone who's an AI engineer here, it's really not that hard to build an LLM, right? Like, I mean, the model architecture is pretty clear. The type of data, it's pretty clear and available. I don't know where, it just doesn't make any sense.
You're in the right building to ask.
Yeah, I know. I mean, I also worked on it myself a little bit, so I also have the first-hand experience. But I just feel like what is the saying? Something like, you don't have to be afraid of an army of wolves led by a sheep, right? But you should be afraid of an army of sheep led by a wolf. And that seems to be sometimes a problem. Also, in the organization, like in the police force, there's definitely progressive parts, and there's people that totally reject the idea of ever doing that at all. So they're like actively fighting against it, which you have in all the organizations. But it seems to me that this is over proportionally existing in Germany. And this is very unfortunate, because probably if you would have the same funds directed to more progressive leadership places, you would also have a lot more fruits by now, or faster step of progress. Yeah. Any other question? Otherwise, yeah.
Just one more. I'm already seeing progress, because Gaia X was the old infra platform. These systems, well, they brought in Huawei to build it, so that was kind of problematic. Now you're actually looking at use cases. Already that makes a big difference.
Yeah.
And I'm guessing you're maybe not using Gaia X or the T-Systems platform for the basic infrastructure here.
Well, I cannot comment. Yes. What I do think, we can still take questions, but maybe something that is quite interesting is what gives me a little bit of hope is that in this organization of the police now, and itself AI, is quite a different new technology trend in the way it's being perceived. For example, I was sitting in the train the other day, and there were two middle-aged women, and they were working in audit, and they were talking about ChatGPT. So they are aware of that there's something really cool to be done, and this is really a trend that is such a massive mainstream conversation now, that there's so many initiatives from, not from all the way up, but from middle to lower level positions in the police that say, hey, I saw this, I think we can do something really cool on my process that I'm supervising or that I'm in charge of. And I have now, for the police, made a backlog, right? If you're a project manager, you know your backlog. Usually you put things you don't want to do in there ever, but don't want to reject. But it's a really long backlog with like over 200 initiatives of people within the organization saying, hey, I really want to use it. Hey, I can really do something with it. So instead of the typical, and it was just maybe also Jim's job a lot of the time, he's the ultra expert, right? And he's trying to convince you like, this is a great tool, you will benefit so much. This is a sales pitch that is coming from the company to the people. But what I found with the AI side is really that people have discovered it, and now they're actually asking for it from within the organization, which makes my job a lot easier. But I think it's quite nice to have this trend, because in the end, you need to have organizational readiness and change. And that happens within the organization. And that's a very nice and a trend that I really applaud. It's really nice that this happens. And this is also very promising that whatever we're going to build for the police in after 2020, the AI cloud, so to speak, that it will be actually used, right? The worst thing is you have some cool tool, but nobody cares. Like, but I don't see that happening. So there's a lot of enthusiasm, and that's great for everybody who's in the tech right now, I think. And also just to really give a benefit to the public that we're going to have a better police service or public service or other private sector service.
Okay, thank you very much, Jordi.